Materials and method. What you did, how you did it. You know what you did. You know how you did it. All you have to do is figure out how to put it down in words so that it makes sense to somebody else. This should be one of the easiest parts to write of your thesis because it's just saying what you did. When you look at materials and methods, all you put in the materials and methods is, what did I do? How did I do it? Sometimes there's a little bit of a justification on specific things, not on the whole thing, because that's in the literature review. That's in the objectives. Materials and methods. What did I do? Cookbook. Spell it out in detail. You're writing a cookbook. You want somebody to be able to bake that cake. You have to put down what you did. It's not a pinch of salt. It's not a smidgen of this or a dab of that. Need to know exactly what you did. It says scientific units. You put it all down in scientific units. Times. How long did it go for? What time of the year did it happen at? Time becomes very important. Dosages. Dosages become very important in these. You know, how much did you put in? When did you put it in? Because all of these things, what you're doing is you're spelling out how you controlled your variables. And as you spell out how you control your variables, you're going to get something really good out of it. Where did the material come from? There's a big difference between buying vinegar at the food store, which is a food grade, and buying commercial acetic acid from a scientific supply store. Basically the same materials, but you've got to know where your source came from and where your material came from. You know, this becomes important to note. Question: could you repeat what you did using only your materials and methods? And that's the whole concept in here. If you went and took your materials and methods and gave it to somebody who didn't know diddly squat about what you were doing, could they repeat what you did? If the answer to that is yes, then you've got good materials and methods. If the answer to that is no, your materials and methods need work. If your committee can't understand what you did, then it's really because your materials and methods really did not explain anything. So materials and methods should be a very easy part to write, but you got to have sufficient detail. You document everything. You got your research lab notebook. You put down everything you did. You start out, when you're in the lab on a daily basis, you put down what you got. You don't start a new day without having a documentation for it. It's supposed to be down in there. If you use a minor or not readily available source, write out what you did and reference it. Let's say you used a culture media that was published by Joe Flynn out of the lesser university of the South Side, and he published it in their journal, which nobody's ever heard of. It's not to say what he had wasn't any good, but when you use that, go out there and cite that that's what you used, but spell out what the material is so that anybody who can go back and look at it and say, hey, this is what we've got. Now, by the same token, if you use Marashi and Skoog's tissue culture media, we know which journal it came out of. Everybody's got a copy of it. It's all you got to do is say, I use Marashi and Skoog's culture media, reference it, and go on, because anybody can find that. Minor source, write it out what you did. If you use a readily available source, just write out what you modified. So if you took Marashi and Skoog's media and you changed the concentration of one of the things, use Marashi and Skoog's media, and what I did was I modified this and I put in this much. And then you reference their media, and that's all you have to do. You don't have to write out all the other things in there because it's very well documented. When you're dealing with it, document it properly. Place things in order of what you did and in order of flow. You started out doing this. You did it in that order for a reason. And when you go through and you did it in that order, and then you say you collected data on this, when you go into your results, that should be the same order you got out of your materials and methods. Because if you're all over the place, people aren't going to be able to follow you. So it should be what you did and in order of flow. Document with pictures that which is important. It is never important that you show up in these pictures. It's never important to take a picture of a machine just to have a picture of a machine. It may be important to take a picture of the room where you did the growth in. Is that really necessary? You have to figure out what is important in the pictures, because if you're doing common things, you really don't need the pictures in it, and that's just going to fill up and take up more space. Location of fieldwork. Give latitude and longitude and elevation. Where'd you do it at? If you say you did it in Tallahassee, Tallahassee's got a lot of different places. The Vineyards is different than downtown. That's different than Quincy. Give a specific area address so that people can go out there and figure out later on, if they need to, they can go back and they can look at it. Give parameter. you're doing an experiment, maximum and minimum temperatures. If it's done inside at room temperature, that's one thing. If you got a low growth room, that's fine. You give the time of the year if it's relevant. If you're doing it indoors, that's not relevant. But if you're doing it outside with natural lighting, we get different natural lighting in December than we do in July. Give the duration of the experiment. When did you start? How long did it go on for? How often did you sample? Interval, because all of these become very important parameters for somebody to go back and use and reevaluate what you did. Example, and this came out of my PhD dissertation. Pen eagle creeping bentgrass seeds were planted in washed river sand in 7-centimeter diameter plastic cups which had drainage holes. Plants were watered alternately with tap water or Hoagland solution containing iron as iron tartrate. Plants were grown at 22 plus or minus 2 degrees centigrade day and 18 plus or minus 2 degrees centigrade night temperatures in a walk-in growth chamber and received 12 hours of light every 24 hours from a bank of 4 GE cool white fluorescent lights located 0.5 meters above the tops of the cups. The lights provided an average of 9,000 lux and relative humidity remained at 80 plus or minus 5%. You could repeat that. It is not difficult to understand exactly what was done. Hoagland solution was modified. Iron came in as iron tartrate instead of iron EDTA or something else like that. It's got all of this information for you. It's put together in a way that you can fully understand it just by looking at it. Here's another example. Fungi were cultured on a synthetic medium containing 10 grams glucose, 2 grams xylose, 4 grams asparagine, 1.5 grams KH2PO4, 0.75 grams magnesium sulfate, and 0.1 milligrams each copper sulfate, manganese sulfate, zinc sulfate, iron sulfate, and sodium molybdate, and 18 grams agar per liter of distilled water. The microelements were added from a stock solution, which means rather than trying to pull out 0.1 milligrams each of those, there was a stock solution that was used to be able to get the proper amount in it. The asparagine was filter sterilized separately before being added to the molten medium. Fungal cultures were incubated under fluorescent lights at 24 degrees centigrade. You've got what was done, the way it was done, and any modifications that were found in it. It becomes a very important sort of thing that you put together what we've got here. The culture media was written out because it came from an obscure source. It was referenced in the beginning. Cookbook style. What did I do? What's in it? How do I make this thing happen?